Hello, and welcome back to another episode of the Med Device Podcast. Today, we're going to be unpacking software composition analysis, talking about where the boundary of software composition analysis is, talking a little bit about SBOMs, SOUP, exactly where the line is between the two of those, and understanding a bit more of what makes up medical devices. I'm your co-host, Trevor Slattery, joined here by our co-host, Christian Espinoza. How are you doing today, Christian?
Yeah, I'm doing pretty good. Leaving tomorrow for St. Louis for some of the holidays, and excited about this topic, though. It's interesting because we have a lot of acronyms. We have SCA, SOUP, and SBOM. It's like, let's make things much more complicated. And we have SAST. Some people loop in SAST under SCA and even DAST. So it's like a bunch of acronym soup.
I think there's a plague across the medtech industry where we try to make everything into an acronym. Oftentimes, when existing acronyms already are in place for some other different terminology, but yeah, it's easy to get lost in the sea of letters and numbers all strung together. But I think it would be great if we can start by talking about what each of these items are, and then we'll dive a little bit more into the details on each one and where it comes into play. But our main
Let's start with
focus
SCA. That's the high level, right?
Yeah, our main focus is that we'll go with the top down, starting with the SCA or software composition analysis, and then we'll talk about how everything feeds into that. So, software composition analysis, as the name implies, is what makes up the software. It's a little bit different than some of the other types of testing or other types of analysis that we'll do, which are more focused on what's wrong with the software, not just what goes into it. Now, part of this process is the downstream effect. You can oftentimes identify what's wrong with your software once you know what's in it. That's generally why we have to do these exercises. But at the highest level, software composition analysis is figuring out a register of what goes into your product, the different source code that you have involved, whether or not you have control over it, and then we dive into some more granularity from there.
How does this even occur, though? I would think if I'm a software developer, I would know exactly where all the software came from that I put into my code in my product.
Well, oftentimes it'll be that you have a big team working on a product. So if you think for a larger medical device company, there might be hundreds of engineers working on a single project. They aren't going to be able to keep track of every single contribution that anyone else has made and across the entire company. So having a way to collect this all into a single place can be really, really helpful. Oftentimes, we may even see that certain dependencies you're including in a program will include other dependencies automatically that you may not have been aware of. So this is a great way to round that up as well. I think a newer problem that has come up in the past couple of years as well is people utilizing AI for their coding that don't actually know exactly what the AI is doing. I've seen just trying around with some of the different AI coding tools, the vibe coding platforms, and then I take a look at my SBOM that I generate at the end of it, and I realize that I added 500 components in 2 hours, and I have no idea what any of them do. Part of my concerns around AI development, and I know that there are guardrails in place to prevent that from happening, but it's definitely a situation I'm sure comes up from time to time.
That's a good point. I forgot to think about AI, but I know someone that developed this like app, a mobile app using AI. They know nothing about programming. They just kept telling AI what to do. And it came up with this app where you could pick the closest coffee shop and then rate it or something.
See, I mean, AI is getting a lot better at coding, and it is kind of crazy now. Anyone can just start making something. I have some concerns when people are using too much AI for developing medical software for a laundry list of reasons, but as a general use case, I think that it's great for making something quick, like track down the closest coffee shop, perfect fit for it.
Not too risky with that. You might get a bad cup of coffee, but that's about as bad as it goes. With medical devices, it's definitely more risky. So we talked about the software composition analysis. So what are all the parts that go into the software? You got third-party libraries. You've got maybe AI-written code that it could borrow a third-party library, but it could generate the code itself, as example. And we got the code that our software developers or engineers create themselves, or as we've noticed quite a bit, borrow from various websites verbatim. So we're trying to figure out where all this stuff came from, all the pieces that make up the code. So we have traceability for everything.
Definitely. Yeah, and I think that you mentioned software engineers taking code straight off the internet. Unfortunately, it is something that we even see within medical use cases, copying hard-coded credentials straight off the internet that then we're able to try to replay against the device successfully. So there is a lot that can go wrong with the makeup of a product. But there are luckily a couple of great tools that we can use to A, understand what we're building into the product a little bit better, and then B, get some insights on what to do about it from there. I think the first and the main one is a software bill of materials or an SBOM, which is
So to be clear, this is a subset of software composition analysis. Part of the under that umbrella is the software bill of materials.
exactly. You can think of it sort of as the output from the process of the composition analysis. So, with software composition analysis, you're identifying, trying to understand everything that makes up your code. Be that something that you pull off of the internet, a third party dependency that you're using, code that you're writing yourself, or code that an AI is writing for you. All of that should get registered as who wrote the code, what version is it, what is the name of the package that you're using. You have a unique identifier to trace back to it. When did you generate this SBOM? Who generated this SBOM? There are a bunch of different factors that you can feed into an SBOM, and then they're very granular, meant to be tailored for whatever specific use case you have. Of course, under the context of a medical device, the FDA lays out some specifications for what they want to see with an SBOM. But as a general use case, it's a great way to think of pretty much the outcome of that software composition analysis. It's a registry of everything that you're building into the product, all of the materials that make up your software.
So this is like if I purchase a Ferrari, I have the right to know like who made the spark plugs, where they came from, who made the brakes, where they came from, the wheels, tires, everything, right? It's like the components that make up the Ferrari.
Exactly. So, a good way to think about it with that example is when you're opening up the hood, think of that as the software composition analysis process. You're looking inside of the device, or in this case, inside of the car, to see exactly what is there. How are these different components connected? This can be another big important thing, and that is an important part of SBOMs is how are you using specific components? You might directly just take a component and put it right into the machine. You could think about the engine that the car is using. The engine is made up of a ton of different parts that are part of the engine, but you wouldn't say directly interact with the rest of the car. These can be thought of as dependencies of a dependency. And that's the way that we need to structure these bills of materials. Unfortunately, SBOMs are usually a lot less cool than opening up the hood of a Ferrari, but the same general concept can apply.
The last Ferrari I looked at, 488 Evo Challenge, the engine was in the back for balance, so it wasn't under the hood per se.
Oh, well, there you go. Under the
Same concept though. You could see the engine through the plastic covering of it. Yeah.
Oh, one of those, like, you can see through the back, that's cool.
Yeah, yeah. I didn't drive that car because the track was too wet. It's too dangerous to drive on the car, so I did the pista instead when I was at Vegas. But yeah, it's from a risk perspective, we want to have transparency. So if a healthcare delivery organization or user of a medical device is going to make a decision about purchasing this device and putting it in their environment, they have the right to know what components make up that device. What if there's like if there's a vulnerable third-party library that's vulnerable to log4j, as example, they may not want to put it on their environment.
Exactly. And this can even apply outside of, well, of course it is an FDA requirement, so it's not something that you should try to omit when submitting your cyber devices. But one question that comes up from time to time is, I'm not subject to FDA, or, I'm not even in the medical space. Do I still need to think about SBOMs? And while you may not have to, they're just a great way to understand what goes into your code. It's overall, I think, a recommendation for anyone building software to understand what components are in their system and how they're using them. Especially on larger, complicated projects. Like I was saying, when you have multiple engineers working on a single project, things can get out of hand very quickly where people start losing track of what exactly has been used where. And so having a good, clean registry of that so that you know exactly where everything is being referred to is a perfect way to bridge some of those problems.
Yeah, and like you said, it's more of a best practice. I know Slack, we use Slack in our organization. They have their SBOM publicly accessible. So if I wanted to like really do some scrutiny, I could look at all the third-party libraries and make a decision like maybe we shouldn't use Slack, we should use something else.
Right. You might identify, oh, well, this vulnerability has a known exploited CVE in it, and we don't want to be subject to that risk. So we're not willing to take on that risk. We're going to use Teams instead. Even though we would never use Teams, we're still diehard Slack.
Just like whenever you use iPhones.
Exactly.
It was funny when I was in Vegas. Melissa had a couple of nursing friends with her, and one of them had an iPhone. And whoever has an iPhone, they make it known that they have iPhone. So every picture had to be with her iPhone because it took so much better pictures than everyone else's phones, apparently.
Well, I will give them credit on iPhones having pretty good pictures, but I just got my new Samsung and they figured out how to bend glass on these new ones. And
Oh, look at
so
that.
I think Android just wins by default with
You
that.
can't do that with an iPhone?
No, I'm sure it's something they're working on, but yeah, they don't have any available iPhones where you can bend the screen. And there are a
Interesting.
lot of Androids that can do that now, like tons of them. There are all these Chinese phones they're making that can bend in every direction. It's really cool.
Another reason to stick with Android.
Exactly.
All right. So with the SBOM, we covered that, I think, pretty decently. The software bill of materials. A couple of gaps, though, is this thing called SOUP, right? We mentioned SOUP, the software of unknown provenance. It's software we really don't know where it came from. And I think before we started recording, you were mentioning there's been a shift in SOUP. So even if it's software that a developer wrote, if they haven't documented it appropriately, it's still considered SOUP. Is that accurate?
Correct. So soup is pretty much any software, code, whatever it might be that you're integrating into the system where you can't trace down the origin. You don't know exactly how it was built, who made it, some information like that. I expect that this is going to become a more and more prevalent situation where we're dealing with a lot of soup in devices with the rampant growth of AI, since it's really hard to figure out exactly what the input was for soup. Soup isn't always the best, or AI isn't always the best about generating documentation for its code, which is another component there. And that's often where there can be a bit of intersection with the human element. So soup, like I said, pretty much you don't know where the code came from. And oftentimes this might mean the engineer working on it before you didn't document what they were doing. They made a bunch of changes to the product and then they left the company. Nobody's sure exactly what the detail or the scope of changes was. They're not sure, even if they have all of the change history through a tool like GitHub or Bitbucket, whatever they're using, but they don't have the documentation supporting why these changes were made, what exactly the purpose of it is, some of the decisions and inputs leading into it. This can fall under that soup category.
So let's take a step from a tool perspective and look at that angle. If I've got an SBOM tool such as FOSSA, Sneak, or a couple of the other ones out there, they're going to identify the third-party libraries, but will any of those identify the soup?
They will identify the soup as a component in the code.
But they can't say where it came from. So they said this is unknown, basically, right?
Yeah, and looking at some of the elements that make up a complete SBOM are going to inherently be missing for that process in a lot of cases. You need to understand who made the product or who made the component name, the component version. And if you're not sure who made the component, that's going to be a missing element. Now, part of why these are required elements for a mature and complete SBOM is ultimately you shouldn't really be using too much code where you can't understand who made it, why it was made, anything like that. I know software can be pretty close to magic sometimes where you're not sure why it works, but it does work. And if you change anything, it stops working. But it's easy for us to get into situations where we aren't properly documenting or registering changes that we're making to the code. And it starts falling into that category where we're not sure if we're able to actually make it modern compliant anymore. But to go back to your original point, the software bill of materials should capture all code in the system, regardless of whether or not we know where it came from.
Okay. And this helps us, like you said, we have a developer that left. We don't, if they haven't documented anything, they may have copied that code directly from somewhere on the internet versus write it themselves. They may have used AI. So we need to understand what the real risks are with that code and where it came from.
Definitely. And we can even think of an example where we have this code, we're not exactly sure about the source of it or what it's doing, but we do see that it's changing. We have multiple different versions of it. And then we're able to go back into our SBOM and say, well, what version are we using within this environment? Since we're not sure exactly, nobody's carefully tracking all of this stuff. And we see a unique identifier. It could be a hash generated of the code base as a whole or of that specific component. It could be, even if we have some versioning schema and you have an SBOM for that, you can trace it back to that component and understand a little bit more information. Even if it's not going to be entirely complete, it's a great way to just get a little bit more insight into the process.
Correct. And since we mentioned the FDA a little bit here, I want to talk about machine readable because we just had a prospect reach out to us because their person that was handling the SBOM tried to submit it via an Excel spreadsheet to the FDA, and the FDA said, kicked it back and said, we need this in a machine readable format. So maybe let's touch upon that a little bit. Maybe you can elaborate what machine readable means and what types of outputs are accepted by the FDA.
Well, the first thing I want to say is this is a very, very common situation. I would say we've probably had closer to 4 prospects in the past month with that exact situation.
I'm just thinking one like I think it was earlier this week or last week. Yeah.
It is a common situation that comes up, and it's partially due to some constraints around eStar and the file formats accepted for an eStar submission. But explaining the process to the FDA, working with them a little bit, they can help get you through the process a bit more. Every reviewer is going to respond a little bit differently. So, as a blanket statement, talk to your reviewer and understand what strategy they would prefer to see there. But talking about machine readable, it's, as you might assume, means that a machine can process and understand it very easily. It is not a requirement for a human readable SBOM to be available, interestingly enough. Now, machine readable formats are generally going to look similar to just big strings of code. So it'll be JSON or XML formatting. These aren't bits of code, but it is just a process for organizing data in a way that is usually really easy to parse by other tools. You can extract specific bits of information. You can work with it, modify it with some existing tools for the specific file format. So it's very easy to modify, manipulate, integrate into existing systems, which is why the FDA prefers to see that machine readable format. It's also just an industry standardized approach. So all industries, I should clarify, automotive uses the same SBOM format as medical, as financial, as legal. So for all of these items, if we have a harmonized approach, it makes it a little bit easier to keep track of everything.
It's basically a protocol. So the machines can ingest the data and then present it to us in a readable format, human readable format,
Exactly.
but they can exchange the data. It's kind of like DICOM, exchanging images in a specific format or anything really.
Exactly. Yep. And similar to DICOM, it's specifically catered for a DICOM image has to be processed by a DICOM viewer or a DICOM reader. So it's not something where you can just open up the image like you would a JPEG image or a PNG picture. So these DICOM images, they're processed by some other platform that lets you, go through multiple layers of the image. That lets you read any notes provided by the physician within that image, any patient information. And SBOMs in a similar process. You can ingest it into an SBOM reader. That'll put everything into a nice, easy to read PDF, into an Excel format, whatever you might need so that it's easier for a human to process.
I think you mentioned JSON. Did you mention SPDX and CycloneDX as well?
I did not. So I mentioned JSON and XML. Those are the file formats. And then for the SBOM formats, we have CycloneDX and SPDX. SPDX is the original standardized SBOM format, focused mostly around legal compliance, understanding how code is used down to the file level very easily. While CycloneDX is a little bit more lightweight, intended for some more security-specific tasks. So while both work great for security purposes, both work great for legal purposes, there's a little bit of a difference in the use case there. CycloneDX is a bit newer and more modern, but SPDX has a very deep support system going back for a long time. Both are completely accepted by the FDA. They don't really show any preference towards one or the other. It's just what ultimately you're using for your internal processes. And the most important thing above all else is just consistency. If you have multiple different components and multiple different SBOMs, then make sure you're doing all within the same structure, the same process, and the same formatting. Don't have disjointed components within there.
One of the things you mentioned, it was debunking this idea that if I have a third-party library that I technically didn't get permission to use, and the third-party manufacturer of the library creator uh, gets upset, they could force me to disclose my source code. Is that I've heard that by quite a few people, but you made it sound like we're kind of moving away from that.
Yeah, that's around the copyleft or the viral licenses. So
What does that mean, copy left?
the copyleft as opposed to a copyright license, and so it's trying to provide more disclosure information.
So it's not copy it's it's not copy written, it's copy left?
Come to think, I know the terminology is for these viral licenses that used to force disclosure requirements. I never thought too hard about the origin of that phrase.
Because there's copyright, like WRITE, but you say it's copy left versus copyright?
Copyleft, yeah. Yeah, there's a licensing method that grants to freedom to use, modify, and distribute a copyrighted work with the condition that any derivatives must be distributed under the same license or an equivalent license. So that is the process where you're integrating these licenses into your system, and that is what forces a disclosure requirement. Now, like you were saying, though, it's not as common anymore. So the GPL licenses, which were the biggest offenders for these viral copyleft problems, aren't too commonly used anymore. It was very common in the early days of open source to try to force everyone to be open source, and there were some legal concerns if you did not properly disclose your source code. The maker of that component that you're integrating into your system that is using that GPL license could come after you to try to sue you to disclose your source code. Now, generally, people are leaning towards more permissive licenses, things such as the MIT license, which is pretty much use it however you want. You don't have to worry about any disclosure requirements. But this is a fairly new shift. So the biggest decline in these copyleft licenses has been in about the past 5 or so years. And while for any new products that are starting up from this point, those are likely going to be free of any copyleft problems. I believe they're only present in 1 or 2% of licenses nowadays. But for medical devices, these take a really long time to develop. Average timeframes can extend past 7 years even. And so we're still developing software from a time where these copyleft licenses were a lot more prevalent, and they can still make their way downstream into devices. We see it, I would say, every day that goes by, it becomes less and less common, but it still comes up on older projects, especially old embedded machines that have been under development for a really long time.
So copyright, I just used AI to come up with an answer here. Because give me an example. A musician's song or a writer's book is protected by copyright, requiring permission to be used or copied. For copyleft, open source software like Linux uses copyleft to allow anyone to view, modify, or distribute the code, but the modified versions must also be open source. So you can't borrow open source code and make it copyright. You can't copyright. You have to keep the left, like you said.
Exactly. And that whole push is in an effort from the open source community to prevent people from taking an open source tool, making a couple of tweaks to it, and then commercializing it. They're trying to keep the community open source, and the open source community wants everything to be open source. And so there's a big push to make sure that we were going in that direction. But like I said, those licenses ended up being extremely annoying for a lot of engineers to use. And so there's been a big push away from them recently.
All right. So we talked about SBOM, SOUP, copyright, copyleft, machine-readable formats for SBOM, the types of formats that are acceptable. The common thing I hear a lot of people talk about is they think SAST, static application security testing, is part of SCA or software composition analysis. Is that fact or fiction?
Well, they are similar processes from a technical perspective, which is where this can often come up as a point of confusion. But from a purpose for the outcome of these activities, they're very different. So SAST
So what's
or
the binary answer?
the binary answer is no, they are not the same. It is false to say they go into the same area, but they do look very similar. Even when we're working through the process, we tend to run both checks at the same time under a nearly identical workflow. So it's easy to make the distinction that they're the same, but they're accomplishing different goals. We talked about some of the goals of software composition analysis, and at its source, it is trying to understand what goes into a product, having a registry of it. Static application security testing, or SAST, this can be similar with dynamic application security testing, or DAST, are when we're taking a look at a source code, or it can be a precompiled binary, but something in static use case, and trying to understand what vulnerabilities may be present in that source code. This can be through, if you're running SAST against any third-party components that you're bringing in as well, any open source components, you may identify vulnerabilities there introduced by the original engineer working on those components. It may be your engineers that are building code to integrate into your product, and you're running SAST against those to make sure that they aren't leaving hard-coded credentials, introducing the potential for memory leaks into the system, not properly sanitizing data where they can introduce the risk of an injection attack. But pretty much this is a focused look into the way that code is written to see if that is introducing risk into the system. Not so much concerned about what the code is, where it is, what it's doing, just saying, are there vulnerabilities in it?
So it can be used to help identify vulnerabilities, but it's technically not part of the software composition analysis.
Correct. Yep. And oftentimes, and we would recommend, you can have them in a single workflow. You can run through your SAST as you're generating and analyzing your SBOM, since they're largely independent processes, but they work really similarly. The tools oftentimes are performing obviously very different checks, but they're doing it in a similar fashion on similar infrastructure, and you can see the results in similar dashboards and output. So running both as a single process in your continuous integration and continuous deployment systems, it's a great way to handle it.
I think we covered everything pretty well here, so we're coming up on time. So what's some last minute words of wisdom, Trevor? You got to deviate from the ones you normally say though a little bit here.
I've been trying to mix it up recently. I'm coming up with a couple of new ones. I think a great one is know what is in your product. It is crazy how often this comes up where we're generating an SBOM and we hear, oh, we didn't even know that was in here. So understand what you're building into your source code. There are a lot of different ways to do this, even if it's someone, editing an Excel sheet to say, hey, I added this new library. Obviously, that's not the ideal way to do it. We talked about SBOMs as a better approach, but understand what you're building into your code, understand when it changes, and then understand that downstream effect. So know what you're making.
It's important to know all the ingredients that make up your product. And it's surprising how many people don't know where things came from. But there's a big push for that transparency and that traceability, and I think we're making progress.
Yep, I think it's getting better day by day that goes on, but it's still, all these requirements are still fairly new, so there's little ways to go for sure.
All right, awesome. Well, thanks so much for tuning in to the Med Device Cyber Podcast. I hope we found this episode on SCA, software composition analysis, and SOUP, and SBOM, and SAST, and a little bit of a different type of soup in terms of word and saying origins useful. So hopefully we'll see you on the next episode, and have a great day.